Remember the network monitor built into the old Nokia phones from last video? It allowed us to get some insight into the GSM traffic between the phone and the base station, and even log messages between the phone processor and the SIM card. But at the end of that video, Vadim said that it's not as powerful as the Calypso chip inside the Motorola phones. So, what is so special about this? On my channel, I always try to encourage you to go to the source of information. So this often means to seek out specifications, documentations, and even the source code, rather than trying to search for the direct solution or even asking on Stack Overflow. But studying and learning about GSM that way is pretty tough.
The specifications of GSM are available in public access for a long time, so one can easily find thousands of PDF documents and get some theoretical knowledge of, for example, how a single frame from the upper layers turns into modulated signal at the physical layer. The problem is that the specifications themselves can only give you theoretical knowledge, but not the practical experience. Fortunately, experimenting with such ancient phones, one can easily get hands dirty with practice.
And so this Motorola phone really helps to get some practical experience.
Unlike network monitor-enabled Nokia devices, some old Motorola phones can give you much more capabilities to play with GSM on practice. I'm talking about the phones based on Calypso chipset. Some time ago, the private documentation for the Calypso baseband, including both register and hardware definition, was leaked onto a public forum by some unknown persons. This leak has made it easier to reverse engineer the firmware of Calypso-based phones like Motorola C123.
So what is this Calypso chipset? Why did you have to reverse engineer the firmware? I mean, nowadays you have open source Android, right? Why would you still be using this old phone with a reverse engineered firmware? How does this make sense? I know a lot of you will probably already know that there is a difference between the baseband and the regular processor of the phone. But I want to make sure everybody understands this, so let me quickly explain. In the first video, I asked the question, how many computers are in your phone? And we learned that the SIM card is actually its own chip running software. The regular processor in phones is sometimes referred to as application processor. This is what you would consider the main CPU that is handling the phone menu, the games, showing stuff on the screen and so forth. On modern smartphones, you can see it as the CPU that is handling the Android operating system or the iOS and so forth. But even though you view this as the phone, this processor doesn't actually do much phone stuff. It does not run all the GSM network parts. The Android operating system does not contain the source code for speaking GSM, UMTS or LTE. This is implemented in another chip inside the phone, and that is called the baseband. This chip is running its own operating system, usually an RTOS, a real-time operating system, and it has its own memory and so forth. This chip is actually controlling the radio part. It is implementing all these complex mobile protocols. And the Android operating system contains proprietary drivers to communicate with the baseband chip. Now, depending on the baseband chip used, there's maybe a debug interface available. You have seen one last video, the Nokia network monitor. But for example, the interface to some more modern Qualcomm basebands have also been reverse engineered. And there is a project called Snoop Snitch, which we might check out another time. It can also be used to analyze GSM packets. And all of that is great. You get the baseband to dump GSM packets out for further analysis. But really understanding GSM and really learn about the protocol, you actually want to have more control over the baseband. And that's why people try to reverse engineer not only the interface to those chips, but to reverse engineer the actual firmware. But this kind of firmware is extremely complex because of all the signal processing, timings and whatnot. I can't imagine reverse engineering that. So insight is very limited and so time intensive. But Vadim already mentioned what makes the Calypso baseband chipset in the Motorola phone so special. The register level manuals seem to have leaked at some point. This document is confidential. It was shared under a non-disclosure agreement in the year 2000. With something like this, you can easily get into legal trouble, and I feel a bit hesitant to show it, but in this case, these documents have been on the internet for many years, that I guess it's fine now. So let's have a look at the general description. Calypso is a chip implementing the digital baseband processors of a GSM GPRS mobile phone. The application of the circuits is the management of the GSM or GPRS baseband processors through the GSM layer 1, 2, and 3 protocols. Calypso architecture is based on 2 processor cores, ARM7 and LED2. So the chip actually includes 2 processors. I think the Motorola didn't have a separate application processor. These old feature phones often had these things combined in a single chip. So the processor that implements some GSM protocol layers is also handling the keyboard input and the display and so forth. I think the ARM processor is doing that. And then we also have the LED2, which is a DSP, a digital signal processing chip. That one is doing the real crazy radio stuff. Here in the document you can also see the features of them. For example, the ARM chip can talk to the SIM card, which it has to, for example, to get the IMSI or doing crypto stuff. But you see, it's a pretty complicated chip with a lot of features. So this documentation is worth gold for anybody who wants to reverse engineer the firmware. When you reverse engineer firmware of embedded devices, you often need to know what certain addresses and registers are for and what the different memory ranges mean. So this document tells you about things like the memory maps. And I just picked a register that sounded interesting. Here's the SIM card related registers. So when you reverse engineer the firmware and something is reading or writing to this address FFFE000, you wouldn't know what that means. But because in the documentation you can see that this address is defined, readable and writable, and it has this name, you know that the code wants to, for example, initiate the SIM card start procedure, I guess. Writing the single bit 1 to one of these bits will cause an event, so I guess with that you can start up the SIM card? No clue, I don't know how this works. But you see why you really need documentation like this to understand the firmware that you reverse engineer. And now imagine you could reverse engineer the whole firmware so far that you can re-implement it, so that you would have a full open source baseband software. Wouldn't that be crazy and super useful? Welcome to the OsmocomBB project. OsmocomBB is a free software open source GSM baseband software implementation. It intends to completely replace the need for a proprietary GSM baseband software, such as drivers for the GSM analog and digital baseband. And if you click on the digital baseband, it will lead to Calypso digital baseband chip is a popular DBB digital baseband implementation for inexpensive feature phones. The Wikipedia article of OsmocomBB also says, OsmocomBB implements the GSM protocol stack's 3 lowest OSI layers of the client-side GSM protocol and device drivers. And it also mentions the motivation for this. After developing OpenBSC, a base station controller, the authors wanted to create a free client-side implementation of the GSM protocol in January 2010. GSM has been in use since 1991, but OsmocomBB is still the only free implementation, excluding failed projects like TSM30 from THC and MadOS. We slowly make our way to the base station side, patience, but what is said here is really important. Osmocom or OsmocomBB is not just a research project that hacked together a proof of concept partial GSM implementation to check out some stuff. When you hear about more modern LTE security research, this is generally the state. OsmocomBB is an actual full open source GSM implementation, and the intention was not security research, but to serve as a full client-side implementation of the GSM protocol, because the authors developed their own base station software OpenBSC. And just to provide a bit more context now, remember the SIM command register from earlier? We can check out the OsmocomBB source code now. Here they define the register address for the SIM command register, including the exact bit for the SIM card start procedure. And in the sim.c file, we can see here a debug output that checks the SIM start command register value and either prints that the SIM card starting procedure is active or not. And we can also see here where this event to start up the SIM card is initiated. In the same file, we can find the Calypso SIM power up function. The comment says it will apply power to the SIM card, so this will start up the SIM card. And here we see a write to the SIM command register, and more specifically the SIM command start bit of that register. Isn't that awesome? thanks to the leak of those documents, the Osmocom project was able to implement an open source GSM stack which can now be used to really interact with the GSM network. So now we know why this old Motorola phone with the Calypso baseband chip is so special.